Hi dear students and those who are watching my video, welcome you all to the BRAINIACS revision series. The intention of this lecture series video is that we will focus on question discussion 100% based on NCERT. Each and every sections of NCERT is covered in this problem discussion. For example, if I take a section of NCERT, say for example, quantization of charges, then I will cover a questions related to quantization of charges. First of all, as an introduction, I'll tell you this is not the exact question given in the NCERT textbook. It's not like that. This is a new questions are derived based on the NCERT concepts, based on the NCERT sections. So we are going to discuss or start the discussions of the 12th first chapter, electric charges and electric field. So here this entire chapter is consist of 73 questions. We are dividing this into 7 videos. First 6 video consists of 10 questions each and the last video consists of 13 questions. So altogether 73 questions. So by learning this 73 question, what are the advantages which we are given to you? You are covering the complete NCERT. NCERT each and every sections you are covering with the concept along with the problems. This is not like just like taking a problem and solving the solution. No, this method is entirely different. What we are going to do, we'll take a question and in the question we will analyze this comes from which section of NCERT. Then we will say the concept behind that particular section or particular question. Then we will go to the solution part. This is how this question discussions will be progressing. The main advantages is like I told, 100% NCERT syllabus is covered and 100% each section of the NCERT is covered. So each and every section you will get a question. You will get one question. You will get maybe 1 to 5 questions or more than that. Depends upon the depth of that particular topic. For example, we have a different topic, for example, electric field. It's a big topic. So you will get enormous number of questions from this one. So we will slowly start what we have given. As I told, it's written on the board, electric charges and fields. That is the first chapter. It is 100% NCERT covered and we are covering 100% the chapter and each of the section of this chapter. That is the speciality of this video series. So let's start with our first video and each video consists of, as I told, it's 10 questions. So let's slowly move. Okay. Okay, so the first question on the board here. Consider a neutral conducting sphere. A positive point charge is placed outside the sphere. The net charge on the sphere is. That's a question. So this question is taken from NCERT section number 142, charge is conserved, and section 143, quantization of charge. Electric charges, electric field, NCERT chapter section 142 and 143. This question is formulated based on the concept is already furnished in the particular NCERT sections. Okay, so no doubt NCERT section, this question is available. So let's analyze this question. What this question is already given. Consider a neutral conducting sphere. So what is mean by neutral? So we have to analyze the question. What is mean by neutral? Neutral means first thing which comes to our mind is like zero. Neutral means zero. But in physics, I will say in another word, neutral is called equal number of positive and negative charges. So 10 positive and 10 negative. So totally what will be the charges of this one? 10 electron plus 10 proton. So total charge is equal to 0. So if a body is there, then it's a neutral body. Total charge of the body is equal to 0 and that is called an isolated conductor. Okay, now the question second statement is talking about positive point charge is placed outside the sphere. A positive point charge is placed outside the sphere. Then what is the net charge here? So this is a question. We can consider this question is like a box. So we want to unlock the box and we want to find a solution for this one. So let's have the key point for this question. What is the key point for this question? The key point what I intended to say is from the NCERT section. The NCERT sections we are comes to the conclusion. NCERT section you have lots of sentences, you have lots of paragraph which we are squeezed into couple of sentences. So this is the key concept from the two sections. What is called neutral conductor? Equal positive and negative charges, that is called neutral conductor. Equal number of positive and equal number of negative, so total number of charges equal to 0. Here you can see one positive negative pair, one positive negative, one positive negative, one positive negative, one positive negative. So we have 5 set of positive and negatives will be here, right? So 1 set, 2 set, 3 set, 4 set, 5 set. So 5 positive negative all together, what will be the charge? Net charge equal to 0. So 5 electron, 5 proton. So all together will be equal to 0. So how we can say 5 electron plus 5 proton. 5 proton is also, but this is negative charges, right? Total will be equal to 0. So this is how Q net equal to 0. Second key point is like total charge of an isolated system is constant. Isolated system means the system has no dependency with any other system, that is standalone. So this sphere has no dependencies with anybody else, has no connections with anybody else. It is staying as it is. That is called isolated system. This isolated system, for that isolated system, charge remains constant. This is a key point. Next, let's look into the solution of this one. Here is the solutions. So we have a isolated system and we have a neutral conducting sphere. So how the neutral conducting sphere, as like we have seen previously, we have a positive and negative charges are there in a body. Now question is given, you are placing in another positive charge nearby this conductor. So what happened? Because of this positive, all the negative charges are moving toward this plus Q, which means all negative charges are populated in this side. So what will happen to the positive charges? The positive charges located over here, all these positive charges, because of the repulsion from these positive charges moving away, these positive charges are moved away. So negative charges are moving in this direction, while the positive charges are moving away from positive because of repulsion. So all 5 charges, we have totally 5, 2, 3, 4, 5. All negative charges are come closer to positive Q and all positive charges are going away from plus Q. So what is the phenomena will be here? What is the net charge in this case? Here also net charge equal to 0 because we have 5 positive, 5 negative. Total charge is equal to 0. We can say Q net equal to how many Q net equal to how many plus and minus 5e electrons plus 5e proton. Total charge is equal to 0. This is what we have. So again the total charge is equal to 0. Here the phenomena happen is called charge distribution, redistribution. Earlier positive with a minus, positive with a minus, positive with a minus. Now the charges are redistributed because charges are moved from one place to another place. Positives are moved to left and negatives are moved towards right side, which means closer to plus Q charges. This is what is happening. So what's answer for this question? Total charge equal to 0 means for this question option number 4 is the correct answer, neutral conductor. Okay, so initially it is neutral, but if you are placing another charge nearby that charge, still its charge is equal to 0. That is the key point in the second part. Total charge of an isolated system is constant. It is an isolated system. Total charge of an isolated system is constant. So what is the meaning of this one? I have a body, initially its charge is equal to 0. Now you placed another body nearby. I don't mind because its charge remains constant. For the system, it is isolated. It has no connections with anybody. So charge is always constant. Our point should comes to your mind. Then the total charge before and after the situation is same, that is equal to 0. Remember, this question is from the NCERT section. 142 charges conserved, 143 quantization of the charges. Hope this question is very clear to you. Answer of this question is option number 4. Okay. Okay. So let's move to the next question. Next question is question number 2. We have question number 2 in front of you. What is question number 2? Charge of 10 microcoulomb. Each are placed at the corners of an equilateral triangle of side 5 centimeter. Then force on each charge is, we have 10 microcoulomb charges are placed corners of an equilateral triangle. What is the side length? That is equal to 5 centimeter is given, 5 centimeter. Then force on each charge is, over charge, because the force on the each and every charge. So we'll take any one charge and we have to calculate the force on that charge. So this question is from there. This question is from NCERT section number 1.5 Coulomb's law. അതേപോലെ NCERT section number 1.6 forces between multiple charges. So this question is based on the two concepts. One is Coulomb's law, forces between multiple charges. NCERT section number 1.5, 1.6. The question is derived from these two sections. Important. So what is the key point will be here? Let's learn some theory before we are solving the problem. First one is called Coulomb's law. We know what is called Coulomb's law. Attractive or the repulsive force between the two charges is given by the formula. This formula 1 by 4 pi epsilon 0 q1 q2 by r square. This k is actually called 1 by 4 pi epsilon 0 q1 q2 by r square. What is the value of this k? This quantity will be here 9 into 10 raised to minus 9. Okay, one point I would like to add here. What is called epsilon 0? Epsilon 0 is called permittivity of air. In the further questions, we will learn more details about this one. But at the moment, remember, it is called permittivity of air or free space. So k in the value 9 into 10 power minus 9 Newton meter square per Coulomb square. In many of the previous entrance examination, whether it is medical entrance or is engineering entrance, there is a commonly asked question is the dimension formula of k. So dimension formula of k can be derived from the unit. I don't going to touch that one because it will comes definitely in the units and dimension chapter and upcoming videos. So now, so this is called Coulomb's law. So this formula we should know. Second concept we want to know to solve this problem. So this is from the Coulomb's law. Coulomb's law is section number 1.5 ആണ്. Section number 1.6 ആണ്. Forces on multiple charges. And the basic concept behind the problem is like resultant of vector. What is called resultant of vector? Let's say I have two vectors, vector number A and vector B. Two vector. The angle between the vector is called the theta. Theta degree is the angle between the vector. And the resultant means total effect of A and B. So resultant equal to A square plus B square plus 2AB cos theta. We must remember this formula. This is actually the backbone of many of the problems in the physics. Resultant of two vector is A square, first vector square plus second vector square plus 2 into first vector into second vector into cos theta. Theta means angle between the first two vectors. If you know these two concepts, problem is easy. Let's read the questions once again. 10 microcoulomb charges placed at the corners of an equilateral triangle. Then the force on each charge is. Force on each charge. Let's move to the solution. Force on each charge is. Say, now we have the three charges will be here. One 10 microcoulomb placed over here and we have one 10 microcoulomb here as well. So we have totally 3 10 microcoulombs. One here and one here. The distance between each side will be equal to 5 centimeter because this is what type of triangle? Equilateral triangle. Angle is 60 here, 60 here, 60 here, everywhere it is 60. Next, I'll take any one charges. What is the question is given? Question is given what is the force on each charge. So you can take this charge or this one or this one. It's up to you. Now let's consider this violet color charge will be here, that is this 10 microcoulomb charge. This 10 microcoulomb charge will have a repulsive force because of this red underline charges. Here see, I have underlined with the red color. So this violet color 10 microcoulomb charge moved like this, repulsion, because of this one, it is undergo a repulsive force, that is called this F. And similarly this charge here also, this black underlined color, this is 10 microcoulomb. Because of this 10, this violet color will move in this direction. So I have marked with the two colors, for example, red F, black F. Red F means repulsion due to this 10, and this black F is the repulsion due to this black 10. Okay, so now we have two forces which are moving in different directions. What is the angle between them? Called theta. So what we are going to do, two vector moving in two different directions, we are going to calculate the resultant of two vector. Fr equal to root of f square plus 2f of cos 60. This is something what a square plus b square plus 2ab cos theta. Same formula we are using. Resultant of two vector. F square plus 2f of cos 60. What is the value of cos 60? Is 1 by 2. So these two and these two will get cancels. Next 2f square plus f square. Answer is root 3f. Here it is root 3f. So it is only root 3f root illa. So only here up to here. So root 3f. Root 3f is the value. We want to calculate the total value. So we are going to do the calculation here. Root 3f. What is called f? Root 3 into k q1 q2 by r square. Normal Coulomb's law. Idane our f. F is nothing but this one. So root 3, 9 into 10 power minus 9, 10 into 10 power minus 6. One charge in the value is 10 into 10 power minus 6. So we have two charges. So 10 into 10 power minus 6 the whole square. Whole divided by distance between the sides or distance between the charges. 5 centimeter. So 5 into 10 power minus 2 the whole square. I'm sorry. Then root 3, I am substituting the value called 1.7. Actually, root 3 in the value is 1.732, but problem solving in we can take it as 1.7. Root 3 in the normal value 1.732, but for problem solving we can take 1.7 for simplicity. So here 1.7 written, here 9 written, 10 square 100 written. This 10 raised to minus 9 10 power minus 12 10 power minus 3 denominator 25 10 power minus 4. It 10 power minus 4 it's going upward, so it become 10. So 2500 cancel, it become 4. 9 is here, 1.7 here, 9 is here. 2500 cancel, it become 4. That 4 is written here. So it 10 raised to minus 4 go to numerator. So it get raised to 10 raised to 4. It 10 raised to 4, 10 raised to minus 3, it become 10. So answer we are getting approximately 612. Approximately 612. Because we are taking root 3 as 1.7, but actual value is 1.732. 1.7 means root 3 1.7 means 1.70 we are considered, but it is slightly greater. So we are getting the answer as 612, but the higher value than 612, slightly higher. So the option matches is called 623.5. That is from the question option number 3. Let's look. Okay, if I remember correctly, it is 623. 612 on options one, so slightly higher because we are taking root 3 as 1.7 on actual value is 1.732. So option number 3 is the right answer. So remember which section of NCERT this problem is asked. Section number 1.5 and section number 1.6. Coulomb's law forces between multiple charges, that is nothing but vector. So Coulomb's law explained here, resultant vector is explained here. This is the key theory behind the question. Next, the solution. So solution is here. Okay, I hope you understood the question very clearly, very easy and simple if you study conceptually. Okay, so let's move to the question. Let's see, this is from which NCERT section? Yes, NCERT section number 1.2 nani questions. It comes in front of us. So two identical small conducting spheres carries a charges of Q1 and Q2. Q2 is very much higher than Q1. Spheres are d distance apart. Forces they exerted on each other is F1. Now the spheres are made to touch each other and then separated by a distance d. The force they exerted on each other is now F2. Then what is F1 by F2? Let's analyze the question before we are moving to this one. So this question is purely from electrical charges. We have to learn this. This is actually the fundamental of this chapter, electric charges. Section number 1.2 nana ee questions derive ചെയ്തിരിക്കുന്നത്. So let's see, two identical small conducting spheres and the charges on Q1 and Q2. Q2 is very much greater than Q1. The spheres, it's a sphere, not a point charge, are separated by a distance d. So now they are separated by a distance d. So two spheres separated by a distance d have a charges of Q1 and Q2, but Q2 is very much greater than Q1. This is what is given in the question. Forces are now they are exerting the forces which is called F. Okay, the forces is called nothing but F1. Next, the spheres are made to touch each other and then now they separated. They touch each other and now they have separated to the same distance called d. Now the new forces is equal to F2. This is what is given in the question. Question is asking what is called F1 divided by F2. Hey, yeah, tell me what is the value of F1 divided by F2. This is what asking. Initially, it's a two sphere Q1 and Q2. So their forces is F1. They are touch, then they are separated. So new forces is called F2. Then what is the ratio of F1 divided by F2? Let's learn some theory behind this one. So the concept is called charge sharing. This is NCERT concept. I squeezed into a simple example here. Let's have two spheres. One sphere name is called A, another one is called B, have a charges of 6 coulomb and 10 coulomb. They are touch each other now. Now they have separated. So if this body is Q1, this body is Q2, then the total charge after separation is Q1 by Q1 plus Q2 divided by 2, which means 6 plus 4 divided by 2, 6 plus 4 divided by 2. So now what is the charges of each body? 5 coulomb and 5 coulomb. 6 plus 4, 10 on 10 by 2, 5 on. So before separation, it has a different charges. Before connecting each other, it has different charges, 6 coulomb and 4 coulomb. Now touch each other, separated. Now they have a fixed charges. Fixed charges means their charges are equal, which means 5 coulomb and 5 coulomb. Okay, so this is nothing but is called charge sharing. The same concept we are using in this problem here as well. So let's look into the solution. So what is given in the solutions? Look here, we have two spheres Q1 and Q2 separated by a distance d. As like questions told, they touch each other. Now they have separated. Okay, so initial forces is K into Q1 into Q2 by d square. After touch, then they separated. What is the force? Q1 plus Q2 by 2, Q1 plus Q2 by 2. What is the force now? K into Q1 Q2. What is now Q1? Q1 is this one and Q2 is this one. So Q1 into Q2, Q1 plus Q2 by 2 into Q1 plus Q2 by 2, which means Q1 plus Q2 by 2 the whole square. Separation is same, that is called d square. Separation is same, d square. So now we got the two things which is given in the problem. We'll move to the right hand side a little bit. Question is given on additional hint called Q1 much greater than Q2. So Q1 much greater than Q2. Let's consider Q1 is equal to 1 coulomb and Q2 is equal to say for example 25. So Q1 is 1 and Q2 is 25. So Q2 square means 625, Q1 square is 1. So the Q2 is 25 and Q1 is 1 coulomb. So 25 1 coulomb and this is 625 and this is 1. So by comparing 625 with 1, or we are comparing 2 into 25 into 1, which means 50. So if you are comparing 50 or 1, 625 is very much greater. is very much greater. So you can say in a problem you have a q1 square will come here, q2 square will come here, because this is nothing but a plus b the whole square, a square plus b square plus 2ab. So here q1 plus q2 the whole square. So what is q1 plus q2 the whole square? We can say q1 square plus q2 square plus 2q1 into q2. So in this example, q1 neglected, this neglected, only what is remains there? q2 square, because q2 is very much higher. It's very much higher. So only q2 will remains in this equation. So f2 I have rewritten as f2 equal to k into q2 square, because I neglected 2q1 q2. I neglected q1 square also, because q2 is greater than q1, means q2 square is very much greater than q1 square and 2q1 q2. So we have to take that approximation in the mathematics only. Question is given this big hint for you. So now f2 means, here this f2 is like this, f2 is k into q2 square by 4d square, because this 2 will come to denominator, 4d square. Now we are calculating the ratio. Now it's very simple, f2 by f1 k q2 square by 4d square, k q1 q2 by d square, d square cancel, k cancel, q1 will be there, 1 q2 and 1 q2 will get cancelled. So q2 divided by 4 q1, this is comes as option number 4. q2 divided by 4 q1, option number 4 is the right answer. Let's have a look into the option. q2 divided by 4 q1 is the right answer for this question. So remember, this is like a concept is nothing but charge sharing. Initially two spheres are separated, touch each other, now they have separated. This question is derived from the NCERT section number 1.2 electric charges. So from the section this question is derived, but it's not like a dicto question, but it is a derived question from the concept learned in the particular section number 1.2. Very important. So what is the concept there? The concept is called charge sharing. I explained with an example here. Next, then the same concept is applied into the problem and we got the solution. So we are learning question. So what are the things we are doing now? We have a question. Then we are saying from which section this question is comes to us. We have a question. The question is comes from the NCERT section number 2. Then for the particular question we are learning the theory from the particular section. Then we are solving the question. So we have a 3-4 steps we are following. Understanding the question. Then we are analyzing which section from the question is coming from NCERT section. Then we are learning the theory. Then we are applying the theory in the problem. So this is how you have to learn the problems while you are learning yourself also. Okay, so let's move to the next question. Fourth question. Fourth question in front of us. A charge q is placed in the middle of two equal like point charges q, which means we have a two charges capital Q, and we have placed a q will be here. For the system to be remains in equilibrium. In equilibrium, what is the value of q is? Question is simple. We have two charges q and the system to be remains in equilibrium. What is the value of small q? We need to find out. This question is comes from NCERT section number 1.5 Coulomb's law, and again the forces between multiple charges. So again the vector concept, again the Coulomb's law. That is the questions will be here. Now for this particular questions, what is the theory we have to learn so that we can attend the similar questions? Very important. Let's look into the key point. Okay. First we understand what is called a system is in equilibrium. Let's say an example. Say here we have a system will be here. Here you have a system. A system will have 1, 2, 3, 4, 5 charges. So if you take any charges and you are calculating the forces on each. Say for example, if I'm taking this charge, these charges will be repelled by this one, this charges will maybe attracted by this one, this charges may be repelled, this charges may be attracted, this repelled, attracted. So if you take one charge and it has an effect of this one, this one, this one, this one, all this one will have effect will be here. It may be an attractive force, it may be a repulsive force, but total force on each element of the system, this big box or the big sphere is a system, and the system consists of, in this example we have 4 charges. So if you take the forces on each charges, the net force equal to 0. That is the meaning of the system is in equilibrium. Net force on any charge of the system is equal to 0. Then we call it as system is in equilibrium. Here we see F net equal to 0, F net equal to 0, F net equal to 0, F net equal to 0 for all the charges, or F resultant equal to 0. We can say like that also, or we can say F net equal to 0. So all charges remains stationary. That is another point. If we have no forces, or all the forces are cancelling each other, or the total force equal to 0, then they say like system is remains stationary. I'll tell an example. I have 2 hands, left hand and right hand. Left hand, one of my friend is pulling with the forces of 10 Newton. Other hand is also pulled by another friend. Left hand is pulled by another friend with 10 Newton. So both the friends are pulling my 2 hands with a force of 10 Newton. So what happened? I am not moving rightward, I am not moving leftward, but I am still remains in my position. So I can say I am in equilibrium, because 2 forces in opposite direction and they're cancelling each other. Suppose nobody is pulling me, then also I am in rest. So as a system, I am equilibrium. If I am not moving right, if I am not moving left, I am in equilibrium. Same cases is applicable for charges also. So equilibrium, the word comes to your mind is net force on any element of the system is 0. A word, question word, it's very important. Here question is talking about system in equilibrium. System in equilibrium means you can take any element of the system. This one, this one, this one, this one, this one. Otherwise, question can say, see, just analyze the question. The system 2 remains in equilibrium. Otherwise, the question can say Q is in equilibrium. If Q is in equilibrium means only the forces on this Q is equal to 0. But question is not talking like this one. Question is saying system 2 remains in equilibrium means all the forces on a particular charge is equal to 0. Not only one, for all this one. Okay, so that is the word meaning of system. A question, while we are reading the question, we should be very careful. The charge Q is in equilibrium. That is different from the system is in equilibrium. System is in equilibrium means everybody will have a force equal to 0. So that is a concept here. So let's move to the solution of this one. Let's say, okay, so question is given. We have 2 equal charges, capital Q and capital Q. So we have placed a third charge in the middle of the system. Next, we are calculating, we can take any charges, right? We can take any charge. So let's take, I'll take in these charges. So any charges of the system is in equilibrium means you can take any charges where the force equal to 0. That's it. So this charges is taken. So these charges will have a repulsive force because of the black underlined capital small q. So this will give a force called F2. Repulsion, this Q will move towards this side, and this blue color Q will also move towards right side because of the red underlined Q. A red underlined Q will give a red F1, black underlined Q will give a black F2. So this one like this. Okay, so this black will give a black force. Similarly, a red will give a red force. Okay, all are positive charges, so this Q will never move towards this Q will never move towards this one. This Q will definitely move towards left, going away because of repulsion. Attraction it comes towards that. It's a repulsion, so going away. Okay, now let's calculate call F1. F1 equal to, F1 means the red color, right? K into Q into Q, these two Q, K into Q divided by distance in the square D square. Second one F2, the black color. So K into capital Q and small q. What is the distance between them? It is nothing but D by 2. So d by 2 the whole square. We have got the second f2. So what is f net? F net equal to f1 plus f2 is equal to 0. That is called system is in equilibrium. So we added kq square by d square, kq divided by d square. E2 square will go to numerator. It become 4. It become 4 here, 4d square. Next, I am taking this part into right hand side, so it has extra minus sign over here. So kq square minus 4kq by d square. Common terms cancel. K by d square, k by d square. 1q can cancel, and we are getting small q equal to q by this 4 will come to denominator, minus will jump here. So q equal to minus q by 4. Simple ആണ് mathematics. K by d square cancel. K by d square cancel. So here we have q is equal to minus 4q. Q cancel. Small q is equal to minus q by 4. Which option is actually option number 2. This is what is written here. Okay, so this is option number 2 is the right answer, minus q by 4. Important, I told a word called system in equilibrium. This is from NCERT section number 1.5 and section number 1.6. E questions derived. We already seen a different model question. This is another type of question. Okay. So now you understand how this is going on, right? Yes, question we are learning, NCERT section we are learning, then we are analyzing the problems. So we have the next question in front of us. Electrostatic force between two small spheres at a separation r is F. Now both spheres comes in contact and separated. Same question we have done previously. Two spheres and our separation between them are total force equal to F. Now they are in touch and then separated. Now the new force becomes 16F by 15. Then what is the ratio of the charges? NCERT section number 1.2 questions is derived, that is called electric charges on electric field. So what is the theory behind this one? Spheres are initially separated, connected, then separated. What is that concept is called? Now you have to tell the concept. That is called charge sharing. We already seen this one, right? Same theory here, no difference. 6 coulomb, 4 microcoulomb touch each other. 6 plus 4 by 2, 6 plus 4 by 2. Let's get the total charge equal to 5 coulomb each. Next, learn this question in the same way previously, but it's a different approach. Why it is different, I will tell you. We have a Q1 and Q2. Initial force equal to K Q1 Q2 by R square. They touch each other, then they have now again separated. Distance is called F, new force is called F2. What is the charge? Q1 plus Q2 by 2, Q1 plus Q2 by 2. 16F by. Now here the problem is different by the method of solution, by the method how we are approaching the problem or how we are solving the problem. So we have 16F by 15 is here. So 16 by 15, K Q1 Q2 by R square. What is called F? F is already written, K Q1 by Q2 by R square. So this is written here. K Q1 Q2 by R square into, and this forces is actually equal to what force? This force, this is called 16F by 15 is equal to this force. What is the force between them? K Q1 plus Q2 by 2 the whole square. 2 will come to denominator as 4R square. So the 60, they are given this 16F. This 16F I solved it here, but the F2 I written here. Right? What is called F2? K into Q1 Q2 by R square. What is Q1? Q1 is Q1 plus Q2 by 2, and this is Q1 plus Q2 by 2. Substituted and we got the answer. So 16F by F by 15. F in a substitute. F2 is K into Q1 plus Q2 by R square. We have simplified. K by R square cancel. K by R square cancels. So what is remains will be here. What are the things we have? It's available over here. So 16 by 15, Q1, Q2, K, Q1 plus Q2, the whole K by R square cancel. We have 4 left here. I forgot to note down here. We have a 4 available here. Okay. So now we are simplifying. We have a 4 available here. So we have it divided by 4. We have divided by 4 available here. So here also we have divided by 4. So let's stop. Let's keep it there. Okay, next we need to find out the ratio of q1 by q2. So what we have done means in these steps, let's analyze this one. See the method, so solution is important. We got this final formula after this one, after all the steps we got this one. Next we want to find out the ratio of q1 by q2. So we are, because q1 by q2 is already given in the option. Okay, q1 by q2. So what I am going to do means, this is a quadratic equation, so it's very difficult to solve. So what I have done means, I need a ratio q1 by q2 format, അല്ലെങ്കിൽ q2 by q1 format. So what I have done means, I taken q1 outside. So 1 plus q2 by q1 whole square divided by 4. So q1 cancel I. So here q2 will be here, and here one q1 left. So 1 by q2 by q1 divided by 4. Now what I'm going to do to find out the correct option, I am approaching the option substitution method. What is called option substitution? What is called option substitution? I have an option, I have to substitute. I'll take option number 1. It's given q1 by q2 is equal to 3 by 4. But in my solution I have q2 by q1. So in the near opposite. So 16 by f into, here 16 by f into q2 by q1. This is the opposite, 4 by 3. 1 plus 4 by 3 the whole square. As I told, I missed to write 1 4 here. So divided by 4 will come. Next we'll simplify these steps. So it's 48 by 45 and divided by 4 here, and this is also divided by 4 here. So what we'll do, we are simplifying this one, q1 by q2 we are substituted here. 16 and 48 value varum, this 45 varum. So it become 48 by 45. Okay, so it become, let me highlight this part. So this part become 48, denominator 45. So this is comes here 48 by 45. Here what will come for us? Here 1 plus 7 by 3, 7 by 3 the whole square divided by 4. So that's what we have written here, 7 by 3 the whole square. So 48 by 45, 7 means 49 by 9 into 4. So this is 48 by 49 is never equal to 49 by 36. 48 by 45 is not equal to 49 by 36. It's not equal. So that's what this option is comes as false. So if you substituted option number 1 and you are getting a mismatching result, these are not equal. These are not equal. So which means that option is false. So what we have to do? We have to go with option number 2. We have to go with option number 3. Then at one point you will get LHS equal to RHS. Left hand side value, right hand side value equal. This is straight we can say 48 by 45, 49 by 36 will never equal. So option number 1 is false. Same steps go with option number 2. Substitute here. If formula substitute here. It option number 1 is substitute the same way. Let's substitute option number 2 and see whether you are getting the correct answer. If you are getting correct answer, stop is there. That is your option. So option number 2 not matches. Option number 3 matches here. So option number 3 is the correct answer. q1 by q2 is equal to 3 by 4. I don't solve it this one because I don't want to dump up with a lot of mathematical stuffs here. So how this problem is running, I solved it with one example. With one example means how we are substituting option number 1. Same way you substitute option number 2, you will get a mismatch. So option number 2 is not the right answer. Then you substitute option number 3, then you are getting the correct answer. So 3 by 5 is the right answer here. 3 by 5. So charge sharing any problem in the concept, we are connected each other, then we are separated each other, we have get the equation. But how this problem is different from this one here, mathematical calculation is little bit tedious, little bit difficult, in the sense you are not supposed to go and solve this equation. This is a quadratic equation. You can solve by the formula minus b plus or minus root of root of b square minus 4ac by 2a. 10th class we have learned this formula to solve quadratic equation. Never do that. It's not the time for doing intelligent mathematical calculation. It's a time for doing and finding the proper solution, because option is already there, answer is already there. You just pick the right one. To pick the right one, perform option substitution. I want to tell you this concept. That's what I formulated this question here. Option substitution, please follow to do. Okay. Good. People will say physics problems are very difficult, physics problems are very tough, and it's very tough to learn. It's not at all tough. I have to say it's not at all tough. It's the way how we are approaching the problem. Okay, if you are studying a problem conceptually, this is such an interesting subject. This is such an interesting problem solving skills. Okay, a lot of practical concepts are involved in this one. So if you are enjoying the video, if you like the video how we are approaching so far, we're learning question, we are analyzing which NCERT it is coming, then we are learning the key point, then we are learning the solution. Never forget to subscribe to our channel. So let's move to the next question. Okay, so force between two identical spheres charged with same charge is F. Identical spheres, charge is F. 50% of the charge of one sphere is transferred to another sphere. What will be the new force? Again, this question comes from the section number 1.2, the backbone of the chapter, electric charges. So what is the key point will be here? Again, here it's called the charge sharing concept. We have two body connected each other, separated. So one body to another body, charge transfer. So same way we are talking. So let's directly move to the question. It's a simple question. We have two body, Q and Q. Forces is K Q square by D square. One body transferred 50% of the charge. 50% means each charge in half. That's 50%. So each charge in the 50% lost. So Q minus Q by 2. So the other body will get that extra charge. Q plus Q by 2. How the transfer is happening? Any methods, normally the physical connection. So it's not talking about it's connected or not connected. It's just a charge transfer. So Q by 2 and Q by 2. Q by 2 lost, Q by 2 get. So this body have Q by 2. This body have 3Q by 2. A kind of a charge transfer. Okay. So if a body connected each other, then definitely the body will have same charge after connection. That's what we have learned here, 6 plus 4 by 2. So for this required a small amount of time to be connected for the charge transfer to be completely performed. But in some cases, in some cases we can do the charge transfer over a wire also, but we can transfer the intended number of charges. Here here we just physically connected, we physically separated. So charges become equal. Okay, here we are taken another mechanism that is not in the syllabus you want to learn, but here I want to take half of the charge and put in half of the charge into another body. So here charges are not equal as like our charge sharing cases. Slightly different this concept. We just transferred one portion of the charge into another portion. Question is not talking about they're connected each other, they're not separated. They say charge transfer. It may be a physical connection using a wire or some other techniques, but that's it. So Q by 2 here and we have 3Q by 2 here. Okay, so now what is the new force will be here? K into Q by 2, Q1, Q2 by D square. Separation is now still remains same. Here also it is D. Separation is not changes. So let's mark it. The separation is same here also. Separation is here also. It is same. That is also called D. Substituted, we are getting K Q square 4. 2 into 2, 4 will come to denominator and D square. So this is called 3, 4 will be here, 3, 4. So 3 by 4. What is K Q square by D square? This is nothing but what called F. So this is 3 by 4 times of F. Simple question. We just a charge transfer is happen in this case. 50% of charge is transfer from one to another component, another charged body. So the answer is 3 by 4F. Option number 1 is the correct answer. Okay, let's move to the next question, 7th question. 2 point charges are placed at a distance r in air, exerted a force called F in air. The distance at which they exerted the same force when they are placed in a certain medium with the dielectric. This question is from the Coulomb's law. Coulomb's law, important. Question comes from the section of Coulomb's law. Coulomb's law where that section contain concept. A concept where a different model. So 2 point charges placed at R in air exerted a force equal to 0. Now they have exerted the same force when they are in a different medium with a dielectric constant K. Okay, so let's see what is I learned from this one. We are going to learn few theory based on the Coulomb's law. Section number 1.5, Coulomb's law. So what is a key point? What is the theory we have to learn for this question? The theory is called permittivity of free space is called epsilon 0. Permittivity of a medium. What is called permittivity? Permittivity is nothing like permission. If somebody is knocking my door, I am not allowing every people to enter into my house. I will allow my relatives, my friends to allow them to enter into a house. If somebody will become as a stranger, I will not straight away directly take into my home. So that is a permission which I am giving. That is my permittivity. That is my permittivity. So air has its own permittivity. It will allow certain things not allow. Certain medium will have certain permittivity. For example, taking copper. Copper is permissible for electricity. But if you take paper is not permissible for electricity. So that permissible level is called permittivity. Free space means air, medium, vacuum, epsilon 0. If you take any other medium like oil, kerosene, any other medium, epsilon. The ratio between these two is called epsilon R, relative permittivity. Relative permittivity. So this relative permittivity is also called a term called dielectric constant. So based on the three understanding, let's formulate the three set of equations over here. First set of equation. F equal to 1 by 4 pi epsilon 0 q1 q2 by r square. Permittivity with free space. With a medium. F Fm with a medium. 1 by 4 pi epsilon m, we are writing 1 by 4 pi epsilon m. Epsilon m is what? Epsilon m is what here? Epsilon 0 into epsilon r. From this one, epsilon m equal to c. From this one, epsilon m equal to epsilon 0, epsilon r. Epsilon r is called dielectric constant K. So I can write like this one. Epsilon m equal to epsilon 0 into K. Epsilon 0 into epsilon r. So that is what we have written. Another formula for medium. F medium 1 by 4 pi epsilon 0 epsilon r. So this dielectric constant normally we are representing using a letter called K. Okay, so you understand permittivity free space, permittivity medium, relative permittivity, dielectric constant. Four things. Our four things based that we are writing three set of equations for medium and for as well as for the air. We have three set of equations, one for medium, one for air, and one for again for medium, but it's based on dielectrics. Epsilon 0, epsilon r. This epsilon r can be written as K also. Okay. Next, let's solve this. Let's read the questions again. 2 point charges placed R in air exerted a force called F. Now they are exerted the same force when they are placed in a certain medium with a dielectric constant R. So the distance at which they exert the same force. That's question key point. Distance at which they exert the same force when they are placed in a certain medium with a dielectric K is. So let's go and see. So we have 2 point charges R and the forces is called K, Q1, Q2 by R square. Now we are placed in a medium. To represent the medium, have put it as a pink color here. So epsilon medium, previously it is epsilon 0, here it is epsilon 0. Here it is called the free space and we have epsilon 0 here. But in the other case we don't have any epsilon 0, but other case we have epsilon m. So what happened in that case is here over here. The distance is, we need the same forces, but the distance is called r dash. So now I put f dash is equal to k dash. It's not same 1 by 4 pi epsilon 0. It's not 1 by 4 pi epsilon 0. It's not equal to this k. What is this k? 1 by 4 pi epsilon m. What is this k? 1 by 4 pi epsilon 0. So both are different. Okay, sorry, this k is what? 1 by 4 pi epsilon m. This k is 1 by 4 pi epsilon 0. Both are different. Okay, so that's what we're marking as k dash. Charge will be the same. Distance is r dash. Question is given, they're exerted the same force. So what we'll do? F dash is equal to f. What is called f dash? F dash 1 by 4 pi epsilon m q1 q2 by r dash square, 1 by 4 pi epsilon 0 q1 q2 by r square. 1 by 4 pi 1 by 4 pi q1 q2 cancel. Epsilon m is replaced with the 1 by epsilon 0 1 by epsilon r dash square epsilon 0 r square. So epsilon 0 cancel. So what is remains will be here? 1 by epsilon r, 1 by r dash square, 1 by r square. What is 1 by epsilon r? I already told, that is also called k, dielectric constant k. So k is replaced, k r dash square. So both the sides we reversed. Numerator become denominator, denominator become numerator. This reverse side. Both side we reversed. So k r dash square equal to r square. R dash is equal to r by k. R dash is called what? The new distance in the medium. So when f equal to f dash, the r dash should be equal to r by root k. R by root k. Okay, when f dash is equal to f, r dash should be equal to r by root k. This is an important concept you have to learn. Important concept. So this is based on the question, based on the permittivity concept. So r by root k, when the option number 3 is the right answer for this question. Okay, hope it is clear. This is from the NCERT section number 1.5 Coulomb's law. Adinte permittivity section, specifically this question is asked. So let's move to the next question. Question number 8. So we have two charges are placed as shown in the figure, which is called 9e and 16e. Where should the third charge place so that it remains at rest? This question is very important. This question is also comes from the section of Coulomb's law. Coulomb's is a big topic. 2 point charges are placed as shown in the figure 9e and 16b. Where should the third charge place so that it remains in rest? Rest means what? Rest means it is equal to equilibrium. Rest means equilibrium. Equilibrium means what? Equilibrium is equal to f net equal to 0. F net equal to 0 only for which charge? Only for the third charge, not for the system. Very important. Previously I told system is in equilibrium means for all charges force equal to 0. But it's not for all charges, it's only for third charge. Third charge is placed so that it remains at rest. It remains at rest. F net equal to 0 only for the third charge. Important questions read them. There is no word called system here at all. That is a difference that previous question this question is. Okay, where should be the place of third charge so that system remains in equilibrium? Third charge is in remains equilibrium means third charge. Let's say I'll take an example. I am standing here. Okay, I am standing here. I have two friends. One friend name is called 1. Another two friend name is called 2. This friend is pulling me. This friend is pulling me. But both are equal to 10 Newton forces. I should move. No, my net force equal to 0 in this case. But now I am standing here. My friend number 1 will be. Okay, so let's make it big upper. I am standing here and another friend is standing here. His name is called 1 and his name is called 2. He is pulling with a forces of 20. He is pulling with a forces of 20. What is my F net equal to 0? Because I am not moving right side, I am not moving left side. My total force equal to 0. But If I'm standing here, one of my friend will be here. His name is called 1 and his name is called 2. He is pulling with a force 10 and he is also pulling with a force of 10. My F net equal to 0. My F net equal to 20. My F net equal to, because friend number 1 and friend number 2 pulling with a forces of 10 each. So total force is 20. Total force is 20. So a system is not a system. A charge remains at rest means it has equal forces in both the direction, one F1 and one F1. Then I can say F net. Two forces in opposite direction means we can subtract one force with the next force and total force equal to 0. So total force is 0. Only one forces are acting in opposite direction. This is not for system, but this is for a single charge. Forces should be opposite. Okay, let's learn some theory behind this one. Third charge is in equilibrium. Where should the third charge placed? So for example, I have two, let's take one example. I have two charges will be here. One is 6E and one is 10E. I placed a charge called 2E here. 2 here means left side I placed, left side. Because of the 6E green color, the green color repulsive force will be here. 2E will be repelled. Because of 10E, 2E will be repelled. So 2E have two forces. One is a green color, one is a pink color. So F net equal to not equal to 0 because two friends are pulling in same direction. So if one hand, two friends, they are pulling me on that side. So what happened? I will definitely move towards right side. So F net will never equal to 0. So it should not be left side. So it should not be left side. Case 2. Suppose I place the charge at the middle. So what happened? The 6E, because of the 6E, 2E will move towards right side. Repulsion. 6E and 2E repulsion. So 2E E side ku povum, 6E E side ku povum. So both are moving in two different directions. And this 2E, because of the 10E, the 2E will repel. Equal charge, positive charge and same like charges will repel. So 2E. So here both forces in opposite direction. One friend here, both are pulling. If the pulling forces are unequal, then F net is not equal to 0. If the pulling forces are equal, then there is a chance that F net equal to 0. So here is a chance that F net equal to 0. F net equal to 0 ku chance undavada. Second case. Third case, if I am placing at the right hand side, the 2 is placed at the right side. What happened? Because of the green color, repulsion. Because of the pink color, repulsion. Both forces are right side. Same again, two friends are pulling right side. The forces is never equal to 0. So this is no chance. Okay, so in the first cases, two forces are left side. F net will never equal to 0. Second case is two forces are one force right, one force left. There is a chance that F net equal to 0 when forces are equal. But third case, two forces are right side. F net will never equal to 0. From the three cases, we can conclude that F net equal to 0 only when forces are acting in opposite direction. Very important one. From the three cases, we can conclude that F net 0, force are equal direction. Next, let's check our understanding whether it is correct or not. Let's take an example. I have minus 6E here will be here. I have 10E will be here. Where to place the third charge so that the third charge in equilibrium? Now you tell me, I have to place third charge here, I have to place third charge here, I have to place third charge will be option number 1, option number 2, option number 3. Think about it. 1, 2, 3. 1 is the point left side, 2 is the point in between two charges, 3 is the point in the right side. Where we have to place the third charge. Third charge means positive charge where we have to place. So let's analyze. So suppose if you placed at the left side plus Q, minus 6E will attract, plus 10E will reject. Minus 6E will attract, plus 10E will reject. Two forces in opposite direction, there is a chance that F net equal to 0. This is one possibility. Second one, minus 6E, 10E. The third charge is placed between the two charges. So minus 6e will attract, plus 10e in the green color, plus 10 the red color, plus 10e will repel. So two forces are in the same direction. F net will never equal to 0. No chance. The third charge should not be in the middle. The next chance, the charge plus q is in the right side. So the plus 10e will repel. The minus 6e will attract. So this plus q charge plus 10e equal charges are, equal means equal, means unlike charges are, so it is repel. My plus q e minus 6e opposite charges, so it will attract. So that green color red color opposite. Red color is due to red circle, green color is due to green circle. Okay, so we have two things, green circle and red circle, because of the respective forces. So F net equal to 0 when they are in opposite direction. When they're same direction, not equal to 0. So here the third charge can be placed in two locations. Where to place the third charge here? Third charge can be placed here, it is true, here it is true, but here it is false. It can be left, it can be right. Understood? Just to look, forces are opposite or same. Opposite means there is a chance that third charge can come there and it is in equilibrium. Okay, now we have learned all these theory cases. Now we'll read the question once again. Two charges are placed as shown in the figure, 9e and 6e. Where should the third charge placed? Third charge is, now we have to say 9e and 6e. Both are positive charges. Like this is positive charges, this is positive. If I place another positive charges, both charges will repel. So F net not equal to 0. But if I place the charges will be here, 6e will repel, 9e will repel, opposite direction. And positive charges are. So third charge where we have to place? In between two charges. So this is which cases will match? Cases this one, 6e and 10e. Positive charges are. So third charge will definitely comes in between, not middle, but in between. F net equal to 0. So let's analyze this one. So 9e and 16e. We have two charges. Suppose I place the charge q at a distance x meter from 9e and 70 minus x meter from 60e, because the distance between the two charges is called 70. I told two forces are equal, then the third charges is rest. Now I'll taking these two forces. First I'll taking these two forces. What is a q? So k into q into 16e, q1, q2. One q is small q, another one is 16q. So q into 16e divided by, what is the distance between them? 70 minus x the whole square. In next charges, 9e small q. So k into 9eq divided by, what is the distance between them? X square. Common terms all cancel out, k cancel out, q cancel out, e, k, q, e all cancel out. 16 by 70 minus x the whole square, 9 by x the whole square. Both side I am taking the square root. I am taking the square root. So it become 4, 70 minus x, 3 by x. I am solving, cross multiplying and solving 4x. 210 minus 3x. 3x will come here. So it becomes 7x. 7x equal to 210. X equal to 210 by 730. So x equal to 30 means 30 centimeter from 9e. So total distance is how much? 70. Total distance is 70. Okay, total distance 70. So 30 centimeter from 9e, but 40 centimeter from 60e. So this is the correct answer. 30 centimeter from 9e. So what is option? 30 centimeter 9e, 40 centimeter from 9e. So these two options are correct. So this is matches with option number 4. Option number 1 and 2 correct. Option number 1 correct and option number 2 is also correct. Both are joining at option number 4. Important ആണ് ഈ questions, very important. It is such a tricky question. നോർമലായിട്ട് നീറ്റ് ആൻഡ് JE എൻട്രൻസ് എക്സാമിന് ദിസ് മോഡൽ ഓഫ് ക്വസ്റ്റ്യൻസ് വിൽ കം. നൗ ഹിയർ ദേ ഹാവ് പ്ലേസ്ഡ് 9E and 16E. Sometimes they will place both are negative values. Then you have to understand the theory. First we have to conclude where I can place left or in between the two charges or right side. Based on that one, we'll place a charges and we'll go and analyze the problem. Okay, that's the key point. F net equal to 0, only forces are opposite direction. Where the forces are comes as opposite direction. In this case, in this particular problem, this examples minus 6E and 10E, there are two chances F net equal to 0, left side and right side, not at the in between the charges. So depends upon the value of charges, it may vary. Okay, so if both are positive charges, definitely at the middle. If both are negative charges, what will happen? Say I am taking minus 6E. Let me take another color. Then if it is minus 6E and it is minus 10E, where should we place the charge? If Q is will be here, this Q is attracted by minus 6E, this Q is attracted by minus, so here F net equal to 0. There is a chance. But if you place it here, the Q, what will happen? This is attracted by minus 6E, this is attracted by 10E. F net will never equal to 0 because two forces are same direction. If say for example, if I am placing the charge here, say for example Q is placed, so minus 10E will attract, minus 6E will attract. So total force F net is not equal to 0. So random minus charge. If both are negative charges, F net will be equal to 0 only in between the two charges. So we should remember such cases. Okay. So it is important to learn such things. So random positive, if both are positive charges, then you can place the third charge in between the two charges. If both are negative charges, you can place it in between the third charge, in between the two charges. So that is important. So let's once again write so for example, we have a minus 6E here and we have a plus 10E will be here. Okay, so let's mark it with the same color. Let's analyze it. So minus 6 is a green color and the other one is a pink color. Okay, so let's make it this as a charges of minus 10E. Let's take it as minus 10E. So what happened this force? Now if I'm placing the third charge over here, Q, it is attracted by the green one will attract and the pink one will attract. So there is a chance that F net equal to 0 here. But if I place the charges over here, Q will be here, minus 6E will attract and minus 10E will also attract. In that cases, F net not equal to 0 because two forces are in the same direction. Okay, so now if I place the third charge over here on the right side here, then what will happen? This pink color will attract and the green color will also attract. In that case, I can say F net not equal to 0. So F net random negative charges. If both are negative charges, definitely it is in between two charges, F net equal to 0. If both are positive charges, then case 2 is applicable. If both are positive charges, it is also in the middle. If both are negative charges, it is also in between the two charges. So two. Okay, then let's move to the next problem. Problem number 9. Forces of repulsion between two point charges is F when these are 0.1 meter apart. Now the point charges are replaced by a conducting sphere of radius 5 centimeter having the same charge as that of a point charge. Distance between their centers is 0.1 meter. Then force of repulsion. Earlier it's a point charges. Separation between them is 0.1. Forces is F1. So we have a point charges. Separation between them is 0.1 and its force equal to F. Now they have replaced by a sphere. Okay, replaced by a sphere. Centers and the separation is 0.1 meter. So definitely then what is the force? What is now the new force? The distance between the center is also 0.5. Then what is the force of repulsion in that cases? Whether it is increases or decreases. Question same ആണ്. ഒരു point charge distance is 0.1. അപ്പോൾ for example F. Now they have replaced by a sphere and 5 centimeter. So distance between them is 0.1 meter. What is a new force? Whether it is increases, whether it is decreases. That is a question. This question is coming from NCERT section number 1.5 Coulomb's law. Let's analyze. Very simple words. Straight away Coulomb's law. F is equal to K Q1 Q2 by R square. So what happened when R square increases? R square increases means F will decreases. Okay, when distance increases, force will reduces. Let's analyze this questions in a simple way. We have a point charges initially. So the force of attraction of the repulsion is K Q1 Q2 by 0.1 meter square, 0.1 square. Now they have replaced by a sphere. What is the radius of the sphere? Radius of the sphere means 5 centimeter. 5 centimeter means 5 centimeter, 0.05 centimeter, 0.05 meter. Idum 0.05. Distance between the centers, question is already given 0.1 meter, which means this distance is center to center distance is 0.1 meter, which means 5 centimeter, 5 centimeter each. Now when they touch each other, question is not telling that it is touching each other, but question is indirectly saying distance between the center is 0.1 meter, means radius is 1 in a centimeter, radius is 5 centimeter, other radius is also 5 centimeter. So one center to other center is 0.1 meter. It should comes as 0.1 meter, means definitely it should touch. If it is touch each other, then only this distance is 5 centimeter, this distance is 5 centimeter, total is equal to 10 centimeter, which is equal to 0.1 meter. Only if it is touch, only this is possible. So definitely spheres will touch. So what happened? Both are positive charges. One charge is Q1, another charge is Q2. Because of the repulsion, all the positive charges are moving right side and moving left side. Both are moving towards two different directions. So all positives are populated here, all positives are populated here. So what will be the new forces now? F is equal to K into Q1 Q2. Now the distance is a distance between two charges. Charges are moved away. Already here distance is 0.1. Now I say the distance from this point to this point. So here we have a small distance extra. Here also we have small distance extra. That extra distance I have taken as D. Okay, maybe I can write the two extra distance equal to D. What is the two extra distance? One is this part and one is this part. This extra distance is taken as D. So total distance between them is what? D plus 0.1 the whole square. So now comparable to this 0.1 equation, this equation's denominator increases. Previously is 0.1, now it become D plus 0.1 the whole square. So denominator increases means the force will be reduces, decreases. So this is matching with our option number 2. I guess yes, option number 2, decreases, is the correct answer for the question. Option number 2, it is decreases. So point charge replaced by a sphere. So definitely they're not, question is not talking about they're touching each other, but the distance, radius is 5 centimeter, distance between the center is 0.1 meter, which indicate it is touches each other. So charges are moving away, so total distance is now not 0.1, charges are moved away, so distance between the charges are increases, so force of repulsion is reduces, decreases. Option number 2 is the correct answer for this question. Okay, so let's move to the last question in this section of this video. Here the question is here: four charges are placed at the circumference of a dial of the clock. It's a clock in the dial. Okay, four charges are placed. If the clock has only hour hand, okay, we forgot about the minute hand. Minute hand we are not minding, only hour hand, that small needle. Then resultant force on the positive charge Q0 placed at the center point. What is the resultant force will be here? Either clock on clock in the dial pad on, so this is a clock in the 12 number verum, 3 verum, 6 verum, 9 verum. So here the question is comes from the section of NCERT section number 1.6, forces between multiple charges. So let's understand the theory before we are moving to the clock dial. We understand the concept using a small square. So let's, for example, I have a square here and four charges are placed on the squares at the corners, Q here, Q here, Q here, and Q here. I'm going to calculate what is the net force on the plus Q charges. So this Q charges, because of this Q there is a repulsive force, it's a repulsion, and these charges, that the top charges, these top charges and these charges will be getting repelled. So there is one F here and one F here, and this Q highlighted here repelled by this Q. So this Q is repelled by the diagonal. So diagonal force, because of the force there is one force will be here, and this is called F. So we have 3F, 1F, 2F, and we have 3F. Okay, so we have 3F due to there are three forces will be here. One is this green one, let's highlight this one, green one, this green force we have, and one is a blue one, let's take a blue one, and we have a blue forces over here, and we have take a pink color, and this is one Q, and because of this Q what will happen, we have another pink forces. Now we have three forces are acting in three different directions. Next, so already one blue color F is there. I'm not disturbing this blue color F, it is already there, but due to this F, due to this F and this green color F, this is angle between them is 90 degree. There is a resultant force, this one FR. Okay, so this FR is the resultant force because of F and because of the pink color F and green color F, we have a resultant force. So total force is now F plus FR. F plus FR. What is FR? A square plus B square plus 2AB cos, angle between them is 90, cos 90. Cos 90 is 0. So we'll get root F. So total force equal to F plus root F. Okay, total force equal to F plus root F. This is a key point. So total force on this given charge, because of all the three charges we are calculated. Okay, so because of the pink and green F, we have a resultant force, and the resultant force is acting in the same direction of the blue color F. So we can straight away add this one. Opposite we will subtract, same direction we will add. So we first calculated the resultant become root 2F. We are adding with the F net. Okay, so the same concept we are going to apply in the dial clock also. Okay, next look into the dial clock. So here you see, first we need to find out the total forces on the charge Q0. We have four charges are surrounding this one. So I have given us a different colors. So let's look into the first one. See this minus Q here, red color, the plus Q, this Q0, what will happen to this Q0? what will happen to this q0? So this q0 is a positive charges, this minus q is a negative, so q0 will move towards minus q0 will move towards minus q. So this our focus is q0, question is telling about what happened to the q0, so q0 moved towards plus q, that's what this red color sign. Okay, similarly this violet color q, the violet color q is also moving towards q0, so it is also pulling like this, so the forces is like this, or forces is opposite direction. So what will be the effect of this one? So let's say this q0 is a charge here, I'm once again telling this q0 so this minus this q0 is attracted or moved towards minus q, so this is the green color sign, minus q is good, so this is clear. Okay, now the blue color plus q with this q0 will move towards plus q or q0 will move away, q0 will move away, like q0 will move away, q0 will never move to plus q. Why? Because this movement is called attraction, it's not attraction, equal charge, so it is moving away, so that's what we have the blue color here. So these two signs are now clear. We'll come here again, importance. So this red color, this q0 will move towards minus q, attraction, so that is what this red color here. Next one, the violet color q0 will be here, so this q0 will attract, no, same charges, it is repel, so this q0 will move away from plus q, it's not going to the violet color plus q, so we have a violet color here. Now we have two forces, these two forces you will give rise to, these two forces will give rise to 1f and these two forces will give rise to 1f. Okay, or you can say 2f, or you can say, I'll say it's like 2f, I will say this is equal to 2f for example, so f and f, so 2f in the same direction, so f plus f 2f, similarly bottom f plus f 2f, so where will be the resultant of two forces act? Now we have the situations like this. How the situation? We have a 2f, we have a 2f like this, and we have a 2f like this, and we have a f resultant like this. If you take a clock over here, we have a 12, we have 3 clock in the 3 corners on it, here we have 6, here we have 9, so the resultant is in this direction. In this direction means the number is between 6 and 9. What is the number between 6 and 9 in the option? That is the resultant force in the direction. What's the number between 6 and 9? 6 and 9 when the option number 2 on 6 between option number 6 and 9. Let's put into the questions with an highlighted color so that it's easy for you to see and easy for you to remember. Okay, so let's mark it like this. This is enough for this. Okay, so now the resultant is acting in this direction. This is called FR. This is called FR. So FR is acting in this direction. So what is this one? This is 6 9. So 6 and 9 in between an option on option number 2, clock 7. So you can see minute hand is 30 minutes, 30 minutes, 30 minutes, 30 minutes. So question is not talking about anything about a minute hand. Question is always talking about hour hand. So our hand is matches with option number 2, that is the clock equal to 7. So time may be 7:30. So minute hand I don't want to bother because everywhere it is 30. Hour only I have to bother, and that is equal to 7. So this is an important questions to remember. I hope you understand everything for the first 10 questions, and let's analyze in the next subsequent video the next set of questions. Okay, so I wish you all the best with your study. I hope you understand. If you like our video series, don't forget to subscribe and don't forget to share to your friends as well. We together will learn and together will grow. Okay, thank you.